Welcome to PV Online, and today we're going to take a look at some problems dealing with projectile motion. Now these are all going to be launched horizontally, and now that causes us to modify our vertical equation so we don't have an initial velocity in the y direction. Okay, the first time that I'm going to use the simulation, let's go ahead and write down the variables that we're given, and I'm going to make my initial velocity in the x direction. How about if we make that initial velocity in the x direction? We're going to make that one 40 meters per second. And I'm going to make the height of the cliff, I'm going to make that 50 meters. And so now let's go ahead and see if we can do the calculations and see if we can get them to correspond with what the simulation tells us. Okay, so I'm going to plug in my values. I want to solve for range. I've got the initial velocity, but I don't have time. We have two unknowns, so I can't solve that. So I have to go over to the vertical equation. Now, my vertical displacement is down. I'm going to end up below where I start, so we're going to make that negative 50, and that's going to equal 1/2 times negative 9.8, because gravity always acts down, times t squared. Now see if you can throw this in your calculator. Go ahead and pause and see if you can calculate the same time as what I get. Remember that the negatives cancel out. Go ahead and multiply the 1/2 times 9.8 first, and then see if you can do the math. All right, we end up with 3.19 seconds. And now I can solve for the range, because the range is going to be the initial velocity in the x direction, which we just said was 40, times my time, which was 3.19 seconds. My range then becomes 128 meters, which matches what the simulation says. All right, let's go ahead and try another one. So I'm going to change the colors real quick so we don't get confused. So let's make this one blue. Now on this next one, I'm going to change the initial velocity. So my initial velocity is now 50 meters per second, but I'm keeping the height the same. The height is still going to be 50 meters. Since I'm not changing the height, what else won't be changing? Now think about where we used the 50 meters. And we used it in our vertical displacement. If this is still negative 50, gravity's not changing, guess what happens to the time that it's in the air? Which means that the time that a projectile is in the air is dependent on the vertical displacement when you're launching it horizontally. Now let's see if the range gets affected. So now I've increased the velocity. It's now 50 meters per second times my 3.19 seconds. And look at what happens to the range. The range increases just like what's shown on the simulation, how all of a sudden that projectile is landing farther from the base. Oops, I don't need that per second, because this is meters, it's a displacement. All right, we're going to go ahead and we're going to change the height and see what changing the height does to the range. All right, so now in this one, all right, let's make the initial velocity 30 meters per second. And I'm going to make the height 40 meters, so I'm going to make it lower. And you'll notice that I'm going to be changing both the range and the time, because my time now is going to be calculated using negative 40, and it's negative because we're ending below where we started. equals 1/2 times negative 9.8 times t squared. See if you can throw that in your calculator, and when we do that, look at what happens to the time. All of a sudden it was 3.19 seconds before. Now my time is shorter. It's going to take less time to hit the ground. So now not only will it affect the time that it hits the ground, it's also going to affect the range because it's going to take less time to get there. So I take my 30 meters per second times the 2.86, and my new range, you'll see, is a lot shorter, is 85.8 meters. Now remember, I'm still using my range equation. These are going to be the two equations you use pretty much this whole unit, so make sure you remember to use them. 1/2 gt squared. So changing the height changed the time. All right, we'll see you next time.